Dear students, very good welcome to my new class. The topic of my class is laws of chemical combinations. Now, what are the laws of chemical combinations? There are 6 laws. One is law of conservation of mass. You already know about the law of conservation of mass in your school level classes. The next one is law of definite proportions. Okay. Next one, laws of multiple proportions. Then laws of reciprocal proportion. Gay-Lussac's law of gaseous volumes, and last one is Avogadro's proposal. Okay. Now I shall discuss the each laws. Now let us see the laws of conservation of mass. You know the laws of conservation of mass. Scientist Anthony Lavoisier in the year of 1789 first proposed this law. He said that in all physical and chemical changes, there is no net change in mass during the process. Hence, he reached to the conclusion that the matter can neither be created and nor be destroyed. Okay? Now, this is during the process. Hence, he reached the conclusion that the mass can neither be created and nor be destroyed. Now, say for example, if there is a ice, okay, ice melts to the water. That means this is in the liquid state. We take the 1 gram ice at 0 degrees Celsius, and if we apply some amount of heat is there, then 1 gram ice is converted to 1 gram water. Okay? Now, if this water is boiled at 100 degrees Celsius temperature in a closed container, then we get the vapor having mass 1 gram. Okay? So, the physical state changes, but the mass of the substance becomes same throughout the change of the process. So, this is the physical change. So, there is no change of mass. Again, for the chemical reaction, say A and B reacts with each other and form C plus D. Okay, C and D are the product molecules. Clear? Now, say the mass of the A participate in the reaction, that is X. If the B, that is the mass of the B is Y, then m gram C is produced and n gram D is produced. So the total mass of the reactant and the total mass of the product become equal according to the law of conservation of mass. That means the mass neither be created and nor be destroyed. Clear? This definition from the NCERT class 11 books. Okay? Book. We know the law of conservation of energy. That means energy of the universe remains same. But after the discovery of Einstein law of relativity, that means E is equal to mc square, here mass can be changes to the energy and energy can be changes to the mass. So now the new concept is here. That means not the only the mass, this is not the conservative in property, and not the energy also this is conserved, But after the discovery of Einstein law of relativity, that means now it is stated that the conservation of mass and energy both are simultaneously conservative. Okay, the total mass and the energy before the reaction and the total mass of the mass and the energy, that means remains same after the reaction. So this concept become changes, and now we can say the law of mass and energy, law of conservation of mass and energy. Okay, the next one is the law of definite proportion. Here we can see, and this statement also copied from NCERT class 11 chemistry book. Here, a given compound always contains exactly same proportion of the elements by weight. Say for example, water. Okay, water is a molecule. Here, the mass ratio of hydrogen and oxygen, that is, hydrogen is to oxygen, that means hydrogen is 2 and oxygen is 16. So their mass ratio is 1 is to 8. Clear? This mass ratio remains same in every where if you collect the water from everywhere of the universe. Okay, the water molecule remains same, so their mass ratio remains same, source may be different. Clear? Another, say for example, if you take CH4, methane, that means carbon is to hydrogen, that means carbon means this is 12 gram and hydrogen is 4, that means this is 4. Their mass ratio is 3 is to 1. If you collect methane from anywhere of the world, their mass ratio is same, that is 3 is to 1. So this is the law of definite proportion. Now there is a point. If you can see the reverse statement of the definite proportion, that is wrong, that is not true always. Okay, now say for example, carbon, hydrogen and oxygen. Clear? If their mass ratio, that means say for example C2H6O. Okay, here the carbon is 2, that means 24, hydrogen is 6 and oxygen is 16. This is their mass ratio. Okay, that means 12 is to 3 is to 8. Clear? CH4, that means their mass ratio remains same, but this is not the same molecules. Okay, mass ratio same means the molecules would be same. This is not true. Okay, C2H6O, that means CH3 O CH3, that means this is dimethyl ether, and C2H6O, that is also CH3 CH2OH, this is the ethanol molecule. So these two molecules are different and their chemical properties also be different, but their mass ratio remains same. So mass ratio remains same, the molecule would be the same. This is not true. The molecule may be different after the discovery of isomers, various types of isomers. We can see in the biomolecules there is a lots of saccharide molecules are there. Say for example C6H12O6, that means this is glucose and this is also mannose, this is also galactose, this is also lactose. Okay, so there is lots of sugar is there, but having their same chemical formula and their mass ratio remains same. So the reverse statement of the law of definite proportion is not true always. Clear? And this law is stated by the English scientist John Dalton in the year of 1803. What he said, that if the two elements can combine to form more than one compound, their masses of element that combine with the fixed mass of the other elements are the ratio of the small whole number. This is very important, small whole number. That means, say, hydrogen and oxygen. Clear? If you take the mass ratio of hydrogen and oxygen, that means 1:8. That means 2:16. That means in H2O, the mass ratio is 1:8. That means 2:16. Thus, another compound having hydrogen and oxygen only, their mass ratio is 1:16, and this is the very small whole number mass ratio. That means 2:32. That means this is H2O2. Okay. Now, more than one compound, the two elements can combine to form more than one compound. One is H2O and another is H2O2. And the masses of one element that combine with the fixed masses of the other element. That means fixed masses of hydrogen. Okay. Here one oxygen atom, only one oxygen atom having the 16 mass can combine with the two hydrogen atom and form the H2O molecule. And this would be 32. Another 2 gram of hydrogen can combine with the 32 gram of oxygen and forms the H2O2. These are the two different molecules. So this is the law of multiple proportion, and this is stated by the scientist John Dalton. Next one is the law of reciprocal proportion. Clear? Law of reciprocal proportion. Now, what is the reciprocal proportion? When two different elements can combine separately with the fixed masses of the third element, the ratio of the masses in which they can combine to form the third element, that will be either same or the simple whole number ratio, either same or the simple whole number ratio, and the ratio of the masses of the two elements can combine with each other. This is proposed by the scientist Richter. Now, say for example, hydrogen, oxygen and carbon. Okay? Hydrogen, oxygen and carbon is there. So, here carbon is to hydrogen, their mass ratio C:8, hydrogen, that is 3:1. That means 12:4. The molecule is 12:4. The molecule is CH4. Okay. Now, hydrogen and oxygen, their mass ratio is 2:16 and forms the H2O. Clear? Now, what will be the mass ratio of carbon and oxygen? Here hydrogen is 4, so if you write 4 is there, that means 16 into 2, that means 32 gram oxygen can react with 4 gram hydrogen and form water molecule. Now 4 hydrogen that remains same. Now 12 gram carbon reacts with 32 gram oxygen, so that forms the carbon dioxide. Here the ratio is 12:32. This is also the whole number. Okay. that is 3:8. This is also the whole number. If there is the if hydrogen and carbon is in the simple ratio, hydrogen and oxygen, that would be the simple ratio, and so the third one, carbon and oxygen, that should be the simple ratio. This is the law of reciprocal proportion. But this law of reciprocal proportion is not true always, because if the non-stoichiometric molecule, that means, say for example, titanium oxide, here the ratio is 1:1, but in some other cases titanium 0.75 is to oxygen, that means here the ratio is 0.75 is to 1, but this molecule does not obey the law of reciprocal proportion. Clear? The next one is the law of Gay-Lussac's law of gaseous volumes. He states that when the gas combine or produced in the chemical reaction, they do so in the simple ratio by the volume, and provided all gases are at the same temperature and pressure. That means, say, nitrogen and hydrogen reacts with each other and form ammonia. Here the reactant molecule nitrogen and hydrogen are in the gaseous state, and the product, that means ammonia, this is also in the gaseous state. We know that one volume of nitrogen can react with the 3 volume of hydrogen and form 2 volume of ammonia. In this law, it is found that 1 mole of nitrogen and 3 mole of hydrogen can react with each other with their ratio of volume is 1:3. So this is the simple whole number ratio, and they can form a product. This will also be in the gaseous state, that means ammonia. Here the 2 molecules of ammonia is produced. So if the reactant molecules are in the gaseous state and having their simple whole number ratio by volume, and the product also in the gaseous state, so the reactants and the product, they also having the simple whole number volume ratio. Okay, provided all gases are in the same temperature and the pressure. Okay, now their ratio would be 1:3:2. That means nitrogen is to hydrogen is to the product ammonia. Their volume ratio is 1:3:2. So this is the Gay-Lussac's law of gaseous volumes. Now the last one is the Avogadro's proposal. This is very important for the chemistry. We know the Avogadro's number, okay? That is 6.023 into 10 to the power 23. Now, the Avogadro's proposal, he stated that the equal volumes of all gases at the same temperature and pressure that contain the equal number of molecules. Okay? Say for example, say at 25 degrees Celsius temperature and 1 atm pressure, 1 atmospheric pressure, there is some gases having volume 10 ml. Okay, there are various types of gas, say for example nitrogen, oxygen, hydrogen, ammonia. So there's various types of gas molecules. So all gases contain the same number of molecules in 10 ml volume of the each gases at 25 degrees Celsius temperature and 1 atm pressure. That means nitrogen contains n number of molecules, oxygen also contains the n number of molecules, hydrogen also contains the n number of molecules, and also the ammonia contains the n number of molecules. So this is the Avogadro's law. From the Avogadro's law, we know that at STP, what is the STP? Standard temperature and pressure. That means 0 degrees Celsius temperature and 1 atm pressure, 22.4 liter of all gases contains the equal number of gas molecules, that is 6.023 into 10 to the power 23. So this number is called the Avogadro's number. Clear? Okay, these are the topics of my today's class. Thank you for your watching. If there is any query, you can write in the comment box. I shall reply. Okay, thank you.